recording? Yeah, let's look at the review sheet together. I'll bring it up and I'll share my screen once I've got it up. You mean the review 2.1 through 2.3
Yes,
measure change?
yes.
Sure. All right, I'm going to share my screen. And we can look at this review sheet together and we can talk about these problems. Can you see it okay?
Yes.
Great. So have you looked at the first question yet? Shall we start with,
Yes, I did.
do you know how to make a truth table to figure out if two statement forms are logically equivalent?
Yes, exactly. That's what I was thinking about. But from what I'm seeing here, it seems like there are two different tables that need to be joined here. Am I right?
Two different tables? No, we can actually just make one table.
Oh, just one table that
Sure.
contains everything, right?
Yeah. Let me stop sharing and let's go through that. And the solutions are posted, but we can sure go through this together.
Yes. We can. I mean, I saw the solution, but just looking at the solution and not actually knowing what everything means, it seems.
All right, well then let's go through it. Do you realize that we need three statement variables, P, Q, and R for this table?
Yes.
Because we have P's and Q's and R's, right?
Yes.
So when we set up the truth table, how many rows is it going to need?
About it.
Exactly. All right, so so true, 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 true.
False,
Oh,
false, false.
yes, under P. And under Q, what do we do?
Is true, false, true, false, true, false.
Not quite. It's,
Or true, true, false, false.
yeah,
Just
yeah, you have to split four in half and half because we have four truths. So split that in half and then you have two truths. When you split two in half under R, it'll alternate true, false, true, false, true, false, true, false. Okay, that's the
okay.
canonical setup. Now we're going to compare the P and Q implies R with the statement form P implies the quantity not P or Q or not R. All right.
Okay.
So, when we scan this, there are a couple of different ways to approach it. We could just go ahead and build up the columns to build this first. And then we can build the not P and the not R columns. Then we can build the column for this conclusion. And then we can build the column for P implies this conclusion. Would you like to do it that way, where we first build up to make number one and then we work on number two?
Yes.
All right. So we're going to need uh, the column for P ANDed with Q. And then once we have that, then we can say, okay, P and Q implies R, and that'll be one. See how I'm kind of just trying to work my way up to it?
Okay.
Then when we get ready to build the column for this expression, we're going to need a not P, and we're going to need a not R, and then we're going to need not P or Q or not R, right? Then we'll be able to build the column for P implies not P or Q or not R. Does that make sense?
Yes.
Yeah, we want to build up to these because if we build up to these, we don't have to work too hard for any given column. You know what I mean? All right, let's execute P and Q. In fact, maybe I should move these down a little bit so that they're on the same line. But anyway, we're going to evaluate P ANDed with Q. Now, do you know the rule for AND? What's it going to take for P and Q to be true? Do you know the rule?
Like when both are truth.
Exactly. Great. So I'm going to go ahead and just number these rows, and I'm going to put my little horizontal line between rows 4 and 5 because it helps settle my eye down. My eye tends to jiggle around. All right, row 1. We're looking at P and Q. What's it going to be in row 1?
It's gonna be truth.
It is. How about row 2?
False.
Wait a minute. P is true in row 2. Q is true in row 2. Both components are true in row 2, just like they were in row 1.
Oh yeah, yeah.
See it?
That's a true statement.
Exactly. All right, great. How about row 3? True ANDed with false. Because P is
It's gonna
true.
be a false.
That's right. Because the Q is false. Good. How about row 4?
False.
Exactly. And how about rows 5, 6, 7, and 8?
I see basically the same pattern. So I'm gonna guess that everything else is false.
Because the P component is false, and that's enough to make the AND operated form false. That's exactly right. So sometimes, we can kind of say, oh, I know all these are going to be false. Great. Now we're going to evaluate P and Q implies R. So this is the column for our hypothesis, and R is our conclusion. Do you agree?
Yes.
So we have to remember the rule for evaluating an if-then statement. Do you know the rule for evaluating an if-then statement?
Isn't it if not P then Q?
Well, here, the hypothesis isn't just P, it's P and Q. So we have a compound hypothesis. Let's just review the rule in general. Let's say we call it curly A implies curly B, okay?
Okay.
If we want to evaluate curly A implies curly B, and the reason I'm using curly A and curly B is because these could represent complicated statement forms. Like, here the curly B is quite complicated. Here the curly A is more complicated. You see what I mean?
Yes.
But the rule for evaluating the conditional, the if-then, what's also called an implication, is it only fails, A implies B, only fails under one condition. It only fails when the hypothesis, which is the quantity on the left of the arrow, is true, and the conclusion, which is the quantity on the right side of the arrow, is false. So it only fails when we have a true hypothesis and a false conclusion. So it only fails there. If both the hypothesis and the conclusion are true, the if-then is true. And if the hypothesis is false, no matter what it is, if it's a false hypothesis, then the if-then is true by false hypothesis, okay?
Okay.
So that's the rule for evaluating an if-then statement. So we're going to apply that rule now to this compound hypothesis. And the conclusion is simple. It's atomic. It's just R. So in row 1, our hypothesis is true, right? Because P and Q is true.
Yes.
Our conclusion is true. So we're looking at true arrow to true. So what is that going to be?
It's gonna be true.
Correct. Now in row 2, we have a true hypothesis because P and Q is true. R, the conclusion, fails in row 2. So what's the truth value going to be? In other words, what is true implies false? True,
False.
that's right. That's the only time it fails. is if the hypothesis, which is P and Q here, is true, and the conclusion, which is R, is false. That's the only time it'll fail. Look at rows 3, 4, 5, 6, 7, and 8. What do you observe about the hypothesis P and Q in all
They
these
appear to
rows?
be false.
Yeah, the hypothesis is false. But when we have a false hypothesis, the if-then statement is true by false hypothesis. See that? Doesn't even matter
Yes.
what the conclusion is. Whether the conclusion is true or the conclusion is false, the if-then statement will be true because the hypothesis is false. So what should we put in rows 3 through 8?
True.
Yep, they're all true. So it's kind of easy when we have a false hypothesis. The if-then statement is true. Good. So we've got the column for 1 done. Now we're going to work on building up to the column for statement form 2. To do that, we're going to build the columns for not P and for not R, and then we'll be able to OR together not P or Q or not R, okay?
Okay.
All right, so help me with the not P. What goes in? So here's P, and the not just flips a bit. So what goes in row 1?
False.
Row 2?
False.
Excellent. Row 3?
False.
Good. Row 4?
False.
Perfect. Keep going. Row 5?
I think everything else will be true.
I think you're exactly right. It's kind of easy because we know that P was true, 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 false, 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 false. So not P is going to be false, 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 true, 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 right? Makes sense. And now we're going to make the column for not R. So what will the column for not R look like when we think about what the column of R looks like?
I think it's gonna start with false and then repeat itself like false, true, false, true, false, true.
You got it. You're exactly right. Nice job. Okay, you with me?
Yes.
And now we're going to execute this great big OR statement. Not P or Q or not R. Now let's just think about how the OR operator works. When it's just two components OR together, the OR statement is true if either component is true or both. Well, when it's three components being ORed together, like we have here, not P is the first component, Q is the second component, not R is the third component. This OR operated statement form will be true if any one of these is true, or two of these is true, or all three of them are true. In other words, this will only fail if all three components fail, because the OR statement is pretty easy to satisfy. It's going to be true if any of the components or all of the components are true. Okay?
Okay.
All right, so now we just got to make sure we're looking at the right columns. We need the column for not P, it's right here, the column for not R, but we also have to look at the column for Q because it's one of the components. You see what I'm saying?
Yes.
All right, so in row 1, what is the truth value of not P or Q or not R?
I think it is true
Yeah, why?
because according to what you just said, if one of them is like true, the
That's
entire thing is true. So I'm saying like for the not P not am I looking the right column
yeah,
or
not
not
P
P and
or
Q
Q.
or Q?
Yeah, the
There's a
Q.
true value there.
Yes, and that's all we need to get the or to be true. Nice. So you do understand. That's great. So you got it. That's or is really easy to satisfy. We just need at least one of these components to be true. So what about in row 2?
It's also gonna be true.
Yep, because we have not R is true. We also have Q is true. That's even more than we need, isn't it? How about row 3?
This one is false.
Yeah, because none of the components are true in row three, right? Good. Row four.
True.
Excellent. Keep going. Row five. We're on a roll.
True.
Good. Row six.
I think everything else is true.
Yeah, because not P is true, isn't it? That's enough. Great. Now we're going to execute the if-then operator. Here's the conclusion, okay?
Okay.
But even more important than the conclusion is the hypothesis, which is P. So we have to check the conclusion. If the hypothesis is true, we have to check that the conclusion follows, okay?
Okay.
If the hypothesis is false, doesn't matter what the truth value is of the conclusion, the if then will be true by false hypothesis if P is false. Remember?
Yes.
Okay, so row one, true implies true.
It's true.
It sure is. Row two, true implies true.
True.
Nicely done. Row three,
True implies false is false.
that's correct. Row four,
True.
and rows five, six, seven, and eight.
All true.
Yeah, because they have false hypothesis. Hey, did I make a mistake on my key on this problem? Because when we look at these two columns, are these two logically equivalent? In other words,
Mm,
are they identical in every row?
no.
No, they're not, because they differ in rows 2 and 3. They have different truth values in rows 2 and 3, don't they? So they are not logically equivalent because their columns are not identical. I hope I have the right solution. Nura, you're there. Have you checked the solutions on the worksheet? Did I screw that up? I'm going to look at the solution set for that.
Good evening, Professor. I've been following along. Yes, I wrote out the truth table for this one, and yeah, mine looks like yours.
Okay, good. Oh, good. It's funny how you think about something late at night. And I was thinking, oh, because I kind of changed the problem around. I kind of edited a form that I had for this review worksheet. I changed it up a little bit. And I was so nervous that I had made a mistake, but I think we did it right. But that's great. So they're not logically equivalent because their columns are identical. There is something that's kind of interesting, though. Look at the column for not P or Q or not R. Compare it to the column for P implies not P or Q or not R. What do you notice about these two columns?
They look identical.
They are. So in fact, this statement, not P or Q or not R, is logically equivalent to P implies not P or Q or not R. Isn't that weird? It's weird the way that can happen, but it's true. But to answer the question that was given in this problem, these two statement forms are not logically equivalent because their columns are not identical. Does that help?
Yes.
Great. Nura, do you have a specific question? It's your turn. Hi.
Hi, Professor. I have a question for the final question in the review. Not the final, number 4 in the review worksheet.
Uh-huh. Number
Um, I
4.
wanted to go over my key and truth tables with you and my results.
Oh boy, oh boy. Okay. So number 4 is an interesting problem. I'm going to get a fresh sheet of paper. This one deserves a sheet of paper all on its own. So this is still the review. Worksheet for 2.1 to 2.3. Number 4. And the original statement is, if it rains, then it pours. And if it pours, then it rains. So what did you use for your key?
For my key, I used P equals it rains
Yep, that's the same thing I used. Uh-huh.
and Q equals it pours.
Great. So when we use this key, when we write the original statement, which is right here, formally, you can see it's an if and only if statement, can't you?
Yes, a biconditional?
It is, because it's if it rains, then it pours, so it's P implies Q, and if it pours, Q, then it rains. So it really is the biconditional. So our job is to look at each of the 4 problems, or 5, I guess, statement forms, 5 or 6. Yeah, it goes to F. So there are 6 statement forms that you get to kind of work on to see if they are, in fact, P implies Q and Q implies P. So tell me what you've got for A. Will you read A to me?
A is if it doesn't rain, then it doesn't pour, and
Mm-hmm.
if it rains, then it pours.
Great. So when you wrote that formally, what did you write?
I wrote not P implies not Q,
Because it doesn't rain would be not P. So not P implies, because it's an if then, not Q. Good.
and P implies Q.
Yep, because if it rains, then it pours is P implies Q, or if it rains, then it pours, right? And how did you simplify that?
Oh,
Because you see, this can be simplified into either if P then Q, or it's logically equivalent to if Q then P. This is the inverse of if P then Q, and that makes it the contraposition of if Q then P. Remember, if we take the 2 components and change their positions and negate them both, we get a logically equivalent if-then statement. Remember?
yeah.
So this is logically equivalent to Q implies P,
Wow.
because the inverse and the converse are contrapositions of one another.
Well, I did not do that.
And that's what you need to do, because when you boil them all down, you're going to either get both Q implies P and P implies Q. And of course, it doesn't matter which is on which side of the and operator, because the and operator is symmetric and doesn't care, right? Or you'll only get maybe 2 copies of one of these, which is not having both of those. But this does boil down to P if and only if Q. So this one is logically equivalent to the original.
Wow.
So you get to play that game with all of them. And it's a great practice. The best reference material to use is in the good stuff folder. There's that really nice reference document, if P, then Q, that tells us so many different ways to say if P then Q. And if we know lots of different ways to say if P then Q, then we know lots of different ways to say if Q then P. You would just switch the P's and the Q's. So I'm going to share my screen again, and just to point this out to you, Darius, that in the Good Stuff folder, we have lots of good reference material. And this document, if P then Q, it tells you about everything you ever wanted to know about if P then Q and more. Here's the truth table for how we evaluate it. Here are the sister conditionals. And this in particular, all the different ways to say if P then Q. We can say, P arrow Q, or we can say Q if P. That's the same thing as if P then Q. Or we could write P only if Q, right? Yeah, I hate the way that does that. I'm just trying to select P only if Q. P is sufficient for Q is another way to say P implies Q. Q is necessary for P is a way to say if P then Q. And then down here, not Q implies not P. This is the contrapositive. It's logically equivalent to if P then Q because it's the contraposition. There's actually even an or statement that's logically equivalent to if P then Q, not P or Q. So you can use this as a reference to help you as you go through the problems in this in the review worksheet, because these statement forms, there's a whole bunch of them for number 4. Like on B, it says it rains only if it pours. So if your key says P means it rains and Q means it pours, then it rains only if it pours. I would first write that as P only if Q and try to figure out what that's logically equivalent to. And we talked about this in class. Is P only if Q logically equivalent to if P then Q? Or is P only if Q logically equivalent to if Q then P? And then this is another one of the ones with 2 negations in it. If not P, then not Q. Well, we saw that one up here, and we already discussed how that's going to be logically equivalent to if Q then P. So use your reference tools, and each one of these will boil down to either if P then Q and if Q then P, maybe in the other order, or it'll boil down to if P then Q and if P then Q again, which doesn't give you the biconditional, it only gives you half, or it'll give you 2 copies of if Q then P. And it's really good practice using only if and the negations that are contrapositive and converse. Nura, does that help?
It does. Can I go over the rest of because I wrote formal statements for all of them.
Well,
Um,
what I'd like you to do, though, I know that did you look at the solutions?
no, I didn't know they were there. I didn't see them.
Well, the solutions are there, and I go through it super duper. See here? I go through it super thoroughly.
Oh,
So you'll be able to check yourself.
okay.
Okay? I don't want to spoil all the fun. But you will, I think you'll find that my solution set is extremely thorough, and it will show you any error you may have made.
Okay. So when I'm evaluating questions like this, I look for contrapositives, inverses, negations, things like that. I look for the sisters and the negation.
Uh-huh, and only if, and honestly, um, necessary and sufficient could also be used. And in WebAssign, there are some problems where you practiced with phrases involving necessary for or sufficient condition for, remember?
Yes.
So there were already, some problems there. You'll need to, be able to be fluent with all of those. And I think next week's quiz, um, um, I'm toying with either giving you all an argument to figure out if an argument form is valid or one of these biconditional problems where you have to figure out if a statement is actually the biconditional. So practice with, go back over your WebAssign. Even if you've worked WebAssign, you get to go back and look at your solutions there.
Okay.
Other
Um,
questions?
I'm sorry. I'm sorry.
Go ahead.
I had one other question. I think it was about this WebAssign. There was the final question.
Uh-huh. In 2.3 part 2.
Yes.
Okay, let me grab that because I actually had WebAssign up. Hang on, let me grab it and put it into student view so I don't spoil it. Because all right, I'm going to view as a student. And let's take a look at 2.3 part 2. All right, I'm going to share the screen again. All right, so it was the last question, number 5.
Yes.
Okay, so the key thing is all of them are lying except for one. And he deduced who killed Sharkey on the basis of these statements. So all of these 4 statements, 3 of them are lies and 1 of them is true. So when you approached it, did you start just by just reading the statements and trying to see if there were any contradictions in those statements?
No, I read it and I used the master it.
Okay. So that's a great way to get help is to use this master it. I will just say if I've tacked this without the benefit of this feature called master it, where you can, get some help, right? I would read these and I would start looking for statements that contradicted each other. And then I would know that one or the other of those 2 people was the person telling the truth, because one of them would have to be lying. And so Muscle says Lefty killed Sharky, but Sacco says Lefty didn't kill Sharky.
So that's the contradiction
Yeah, they
to
cannot both be telling the truth. One,
ah.
so right off the bat, we know either Muscles is telling the truth or Sacco is telling the truth. See what I mean?
Yes. Because
Like
they both
yeah, right? Like they can't both be true. Now that's the way I would approach it, but there are other good ways to approach it. Like if you read through here, Fat says Sacco did not kill Sharky. Well, that is consistent with both what Muscle said and what Sacco said. So we really can't tell much yet, from that, right? Because Hang on though. If we already know that either Muscles is telling the truth or Sacco is telling the truth, could Fats be telling the truth?
Yes? Because he's talking about shark, because he's
Oh,
talking
wait a
about
minute.
Sacco?
What? Oh no. Yeah, he could be. Because if Lefty didn't kill Sharky is true, if Sacco's telling the truth, then it could be that he says only one of these statements is true, right? Right. Doesn't he say all of them are lying except for one?
Yes.
So already, don't we know that either Muscles is telling the truth or Sacco? Could they both be lying?
Yes, maybe.
Is there any way that, but aren't these two statements negations of one another?
Yes.
So exactly one of these is true.
Wouldn't Fat's statement be, I guess it's not a negation of something.
Yeah, it's not a negation, so it's not necessarily, so we don't know whether Fats is telling the truth or not. But either Muscles is telling the truth or Sacco. It's got to be one or the other of them that's just telling the truth. We just don't know which.
So I have a question.
Yeah, yeah.
So what about C? What is Lefty saying? Because basically she I don't know, he or she mentions two people in her statement. I don't
It
know.
kind of sounds
Two,
like those two people, Sacco was shooting craps with Muscles. I think Lefty's saying these two people were busy doing
yes.
something
So
else. He's
they
saying
put
neither one of them killed
yes.
Sharky. So if that's a lie, see, this is what I'm going on. I know that either this is the guy that's telling the truth, or either Muscles is telling the truth, or Sacco is telling the truth. Okay, I don't know which, but I know they they can't both be lying and they can't both be telling the truth because their statements are contradicting one another, right? Like they see what I mean? Either Lefty killed Sharky or Lefty didn't. One of those is true. So we already know that it's either Muscles or Sacco who's telling the truth. So that tells us that everybody else is lying, doesn't it?
Is it because Muscles and Sacco both start their statements with Lefty and Fats and Lefty start with Sacco? Because couldn't Fats be telling the truth?
Oh,
Oh,
it says that all were lying except one. See that? See the detective Sharp interviewed the men and determined that all were lying except for one. So he has already told us this much, that only one of these statements is true. We don't know which one is true, but we have been given that much information that only one of these statements is true. Do you see what I mean? And since Lefty killed Sharky and Lefty didn't kill Sharky, are negations of one another. They have opposite truth values. One of these is true. We just don't know which one. But it does tell us that either Muscles is telling the truth or Sacco is telling the truth, which tells us right now Fats is lying and Lefty is lying. See what I mean?
oh,
So, I mean, if Fats is lying and he says Sacco didn't kill Sharky, I'm ready to say Sacco killed Sharky. Is that what you concluded too?
yes.
Uh-huh. And
So
so,
I'm still stuck on two people though.
okay, do you understand that part of the premise is that all were lying except for one?
Yes.
All right, that means three of these four statements is false. One is true. We don't know which one, but check it out. if two statements are negations of one another, and that's what Muscles and Sacco's statements are. They are the negations of one another. One thing we know about negations is they have opposite truth values. We don't know which one of these two is true, but we know one of them has to be true. So that tells us right away that Fats and Lefty can't be telling the truth because either Muscles or Sacco is telling the truth, even though we don't know which one right now. And since Fats is lying, his statement is that Sacco did not kill Sharky. That has to be a lie.
Oh.
So it means Sacco had to kill Sharky because Fats is lying because he's not Muscles or Sacco, who are the two that might be telling the truth. We just don't know which one. But now we do know which one. Was Muscles
Oh.
telling the truth or was Sacco telling the truth?
Sacco was telling the truth.
That's right. Sacco said Lefty didn't kill Sharky, and that's right because Sacco killed him. All right, so Darius, do you understand why either A has to be true or D has to be true? Do you understand why that is? Because that's, I think,
Ye-
where you were getting stuck.
yes, I think I understand it now.
Yeah, negations have opposite truth values from one another by definition. So one of those has to be true and one of those has to be false because those statements are negations of one another. It's fun though, isn't it? And
Yes.
Lefty was lying that Sacco was shooting craps with Muscles when Sharky was knocked off. Basically, he's saying Sacco and Muscles couldn't have done it. And if that's a lie, it doesn't mean they both did it. It means, one of them did it. And if,
So
mhm,
so we know that Fats and Lefty are lying because Muscles and Sacco are the only two that could be telling the truth.
exactly. Because the
But then
statement,
if they are both saying the truth, it means that only Sako might be telling the truth here because he said Lefty didn't kill uh Sharky.
that's right. We figured that out at the end. Sacco was the one who was telling the truth. But at the beginning, we know it has to be Muscles or Sacco telling the truth. And then when we look a little deeper, we realize, oh, okay, Sacco did kill Sharky because Fats is lying. And that means Sacco is telling the truth. Lefty didn't kill Sharky. Sacco did. Yeah, I thought y'all might enjoy that.
Yeah, it's a little confusing.
Sure. It is a little confusing. And you know what? Let me just show you something even a little more confusing, but fun, really fun. There's some other problems at the end of the section. Let's look at the ebook in this section 2-3 that are really fun, but puzzles. So in 2-3, let's look. I'm going to go here. Yeah. Oh, yeah. Okay. So section 2-3. Exercise set 2.3. If you look at number 38. Okay, so number 38 talks about this island. It's called the Land of Knights and Knaves. And this is what happens on this island. The natives live there, okay? And every native is either a knight or a knave. Knights always tell the truth and knaves always lie. So knights are like, knights in shining armor. They're good, they always tell the truth. Knaves are liars. Everything they say is a lie. So here's like the first one. Two natives address you as follows. Native A says, both of us are knights. B says, A is a knave. What are A and B?
I think they're both lying, so I think they're both knaves.
But if they're both knaves, B said A is a knave. B didn't say anything about himself. So B would be telling the truth if they're both knaves.
Oh, oh.
So they can't both be knaves because if they were both knaves, they would both be lying. That'd be fine for A, but B wouldn't be lying if they're actually both knaves. A as a knave would be true. So they can't both be knaves. Could they both be knights?
Then both statements would have to be false.
If
Oh,
they
well,
were, no,
no.
no, knights means knights tell the truth.
Oh,
If they were both knights, both statements would have to be true, right? Is it possible for both of those statements to be true?
but if B is true, then A can't be true.
That's right. So they can't both be knights either. So they can't both be knaves and they can't both be knights. So it's one of each. The question is, which one is which? Okay.
So I'm guessing B would be the knight.
Yeah, because they can't both be telling the truth. It's consistent for both of us are knights to be untrue and A is a knave to be the true statement. So yes, B is the knight and A is the knave. And you can make a truth table, under A is either a true, true, or he speaks false, false, and B either speaks true or true or false. And you can go through each row of the truth table, which is basically what we did. And we ask, is it possible for that row to be the row that actually happens here? Well, they can't both be truth tellers. So row one of the truth table is no go. They can't both be liars. So row four of the truth table can't happen either. It turns out the row that happens is where A is speaking falsely, and B is speaking truth. So that would be row three. So only row three of the truth table is what can happen consistent with that row and these statements. Anyway, this is number 38 at the end of the text, and there's several more. And in fact, D is really interesting. So I encourage you to play those games if you want more fun. Yeah, the answer is, and here's one explanation, you know, and they give, they give names of rules and stuff, but uh, you don't really need to know the names of the rules to understand why this turns out to be that A is a knave and B is a knight. These are fun. You might think you need 64 rows in your truth table to deal with part D because we have six uh, natives, and when you have six variables, you need 64 rows in your truth table, but you don't. It's really only six. There are only six possibilities that none of them are knights. One of them is a knight. Two of them is a knight. Three of them is a knight. Four of them is a knight, or five of them are knights. Yeah, those it really turns out to be only six possibilities, and you can figure it out. So, oh
Okay,
yeah,
I have a question.
sure.
We do we have a quiz tomorrow?
Yeah, I'm thinking about giving a quiz about argument validity, invalidity, or um, just some more practice with if P then Q, different ways to say if P then Q. I'm thinking about it. Um, we'll definitely have one this week,
Okay.
and it would be on this material that we've covered so far. It wouldn't be on, anything we've
Yeah.
covered. I just want to keep people up with the material. I want to keep people working and motivated. And I think quizzes are very motivating. Do you have any other questions? Definitely check out this document, if P then Q, okay? Like really
Yes.
check it out. And then, here's a do later, okay? If P is it rains, I'll just give you a couple more statements. And Q is it pours. I won't say if, I'll just say this is the key. Which, if any, are logically equivalent to P implies Q and Q implies P. Raining is a necessary condition for pouring, and if it doesn't rain, then it doesn't pour. Raining is a sufficient condition for pouring, and none. It pours only if it rains. Just a couple more to practice on. Okay.
Okay.
Okay, thank you.
As if you don't have enough already. But at least this way I'm giving you a little more practice with necessary and sufficient. All right. Thanks for playing.
Okay.
Thank you, Professor.
My pleasure.
Thanks
Have a
a
good
lot.
evening.
See you tomorrow or Tuesday. Bye.
Bye.
It's gonna be tomorrow, definitely.
Okay.
Yeah, I gotta get ready to go to work.
Oh my goodness. You work at night?